All right, guys, so we're going to continue on with our lesson from yesterday. And it looks like we finished with this problem here. We're going to start with it, because I think we finished the one before it. Yes? So, we're continuing on with factoring these quadratics. And with factoring a quadratic, there are 5 main steps that we go through. And the first one is looking at it and determining if it has a greatest common factor. If it does, we're going to factor it out. We're going to pull it out of all 3 terms. If we look at this here, 2x squared, 7x, and 6, is there a number that goes into all 3 terms? No. So there is no greatest common factor, which brings us to step number 2. Our 2 sets of parentheses with 3 spaces. All right, let's focus up here. So we have our 2 sets of parentheses with 3 spaces. So that takes us through steps 1 and 2. Step number 3 is to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here it is positive. So the signs are the same, and they're going to match the sign of the middle term, which is also positive. So we would have plus and plus. Any questions on steps 1 through 3 so far? Step number 4, find the factors of the first and third term. First term is 2x squared. Our third term is 6. So if we're looking at the factors of 2x squared, well, x squared's only factors are x and x. Now we do need to look at the factors of 2, 1 and 2. So we do need to put those factors in. And really, we only need to put the 2 in because wherever the 1 is, it's understood to be there with x, because 1x and just x are the same thing. So where do we want to put the 2? In front of the first x or the second x? Either one will work. Now we do need to find the factors of 6. 1 and 6, or 3 and 2, 2 and 3. So we do have 2 sets of factors, 1 and 6 and 2 and 3. Which set of factors do we want to try first? 2 and 3. Which one do we want to put in the first parenthesis, and which one do we want to put in the second? 2 and 3. And the last step in this process is to check to make sure these work. Now we don't need to multiply the 2x times x, because 2x times x is still 2x squared. And we got 2x and x from the factors of 2x squared, so we should get back there. We don't need to do the 2 times 3, because 2 times 3 is a factor of 6. They will multiply together to get us back to 6. Now 2x times 3 is 6x. 2 times x is plus 6x plus 2x is. Is that the middle term that we want? No. Before we switch anything else, is there a greatest common factor in that first set of parentheses? Between 2x and 2, there is a greatest common factor of 2, yes?
Thank you, Mr. McClendon.
If, by the way, guys, this is something that's nice to know. If there's not a greatest common factor to begin with in the original quadratic, there can't be a greatest common factor in either of the parentheses. So having the 2 and 2 here wouldn't work. But that also means we can't put 6 with 2x, because 2x and 6 has a greatest common factor of 2. Now if we did try this setup here, 2x times 1 would be 2x. 6 times x would be plus 6x, and it would give us 8x. So we can switch the 2 and the 1, or the 1 and the 6. 2x times 6 is 12x. 1 times x is plus x, which gives us 13x. Well, there is one we didn't try with the 2 and 3. We didn't put the 3 with the 2 and the 2 over here. 2x times 2 is 4x. 3 times x is plus, and 4x plus 3x is. But the more of these that you do, the more familiar you'll get with them and the easier they get. Questions on this here? Let's look at the next one. So we want to factor this here. And again, the first thing we would always need to look for is the greatest common factor. Is there a greatest common factor between 4x squared, 7x, and 3? No. That means we can move on to step number 2. Our 2 sets of parentheses with 3 spaces. Okay? Make sure the first 2 steps.
So you said on the test, they're not going to be like this, right? You said they're going to all be able to be factored.
The ones that I do ask you to factor will be factorable. Because if it's asking you to factor it solved by factoring, they will be factorable. I'm not going to give you a non-factorable one on the factoring part of the test. Now, not every quadratic is factorable. If it's not factorable, we have to do it a different way. And we'll go over those later in the chapter. Now, step number 3, find the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is. So the signs are the same and they match the sign of the middle term, which is they both be negative. All right. Let's focus back here. Step number 4. We need to find the factors of the first and third terms. Now the first term is 4x squared. Well, the only factors of x squared are x and x. And since it's in the first spot, its factors x squared are going to go in the first spot in each of the parentheses. Now the factors of 4. Which one do we want to try first? 1 and 4 or 2 and 2? 2 and 2. Factors of 3 are 3 and 1. So the factors of the third term, 3 and 1. Which one do we want to plug in first? Now we have this set up, we can move on to step number 5, which is check. 2x times negative 3 is negative 6x. Negative 1 times 2x is negative, which gives us negative 8x. So one thing we could do is switch the 1 and 3. Put the 3 first and the 1 second. And we can check this. 2x times negative 1 is negative 2x. Negative 3 times 2x is negative. Well, realistically, because the first term was 2x and the other one was 2x, they're both minus, it's really going to give us the same answer. Okay. Where do we want to put the 1 and where do we want to put the 4? 4 first. Now we can check this one here. 4x times negative 1 is negative 4x. Negative 3 times x is negative 3x.
Let's go.
Which gives us
That was 8.
negative 7x. Is that what we wanted?
Yes.
And again, the more of these that you do, the more you'll get comfortable or familiar with how the numbers are going to work together to give us that middle term. And you'll get faster at these, or being better able to predict which ones or which set of factors are more likely going to give us what we want. Questions on this here? Are you ready for the next one? Always start with the greatest common factor. Is there a greatest common factor? So we move on to step 2, our 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. So that means one of them is going to be positive
See, I said both.
and one is negative. It doesn't matter which one we put as positive and which one we put as negative. We just have to set one as positive and one as negative.
Hold on, let me do the same thing you did. Okay.
Because for the third term here, for 7, so we'll go on and get the factors of 7 because it's 1 and 7, yes? I'm just going to throw those in so that we have it. Now to get the third term, when we're multiplying this back out, we do this 1 times 7. To get a negative number, one of them has to be positive, one of them has to be negative. That's the only way we can get a negative number, is if we have that opposite sign. And that's why that works there. That's also true with when the third term's positive. They either both have to be positive or both negative. That's the only way we can get a positive third term. Now, one of the other things that's nice, or the reason I like doing the signs before we find factors, is because here it's not bad. Negative 7, the factors for it, if we were applying the signs, would be negative 1 times 7. Or negative 7 times 1, if we had to take the sign into account. But step 3, the fact that we said the third term's negative, so the signs are opposite, plus and minus, we took care of the signs. We don't have to worry about it being negative 7 anymore. It's already taken care of. So now we're just worried about the factors of 7, which is just 1 and 7. There's only 1. We're not worried about here where there's 2, because we have negative 1 and 7, or 1 and negative 7. Which for this here, that's not bad. Now, if I said negative 24, well, we'd have negative 1 and 24, 1 and negative 24, negative 2 and 12, 2 and negative 12, negative 3 and 8, 3 and negative 8, negative 4 and 6, 4 and 1, 2, 3, 4, 5, 6, 7, 8. If we're actually looking at it with the factors with that sign. If we take that away with that third step and just look at the factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. We cut it in half because we're not having to worry about the sign. Which one's going to be positive, which one's negative. We're just worried about the factors. Y'all see that there. That's one of the nice things I find with the way that I do this here. We're not too worried about the signs. When we check it at the end, it'll tell us for sure if the signs are correct. Now, the factors of the first term. 2x squared. We would have x and x. 1 and 2. So where are we going to put the 2? And then we can check this here. 2x times negative 7 is negative 14x. 1 times x is plus x, which gives us negative 13x. Is that the middle term we wanted? No. I'm going to flip the 1 and 7. Because if I wanted to, I could have switched the 2x and 1x. We just need to flip one of them. Because there's only one set of factors of 2, only one set of factors for 7. So we're going to have to switch one of them. 2x times negative 1 is negative 2x. 7 times x is positive 7x. Negative 2x plus 7x is 5x. And that's the middle term we wanted, yes? We would need it to be negative, yes? Just in case. So is this actually the correct middle term? Because we got, what, 5x, yes? We need it to be negative. Did we get the correct number?
Yes.
We got the correct number, but wrong.
Sign.
We need the sign to what? Change, yes? We needed to change from positive to negative. So why don't we just change the signs? Because if you get the correct number but wrong sign, flip the signs. Because if we wanted to keep the signs the same and change the numbers, it would mean we'd have to change the 2x and x. They would have to switch, and the 1 and 7 would have to switch. We'd have to change all the numbers, or we can just flip the signs. Because if we check this here, 2x times 1 is now positive 2x. Negative 7 times x is now negative, which now gives us now the only time we would have to do this switching the signs is if we have one positive and one negative. We do have those opposite signs. If the signs are the same, we're not going to have that come into play because it should still match up. Questions on this here? Any questions on any of this so far? I think, is this the last one or do we have one more after it?
Here's the last one.
Last one.
It's the last
All right. 3x squared minus 7x minus 6. Is there a greatest common factor? Do our two sets of parentheses with 3 spaces. The next thing I do is the signs. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here it is negative, so one's positive, one's negative. Now again, whichever one you want to put the positive with or negative with, it does not matter. Because as we saw in the last one, we had to switch it. So if I do this here, negative and plus, and we get it right, that's fine. If I need to switch it, we can switch it. That's the nice part about the checking step at the end. Because at this point, we just need to pick one to be positive, one to be negative. Since we know this third term's negative, we're going to have one of each. We just need to pick which one's going to be it for now, and then we'll check at the end. Because either we got it right or we need to fix it. First term, 3x squared. We will have x and x. 1 and 3, where do we want to put the 3? Now the factors of 6 are 1 and 6 and 2 and 3, yes? Now we said a minute ago that the quadratic we're starting with does not have a greatest common factor, yes? So can there be a greatest common factor in either set of parentheses? Well, no. If there's a greatest common factor to begin with, then it could show up. But if we've removed it or there isn't one, that means neither one of these parentheses can have a greatest common factor, other than 1, but 1 doesn't do anything or change anything. So could I put the 6 here? Because 3x and 6 would have a greatest common factor. And if that did work out, it would mean that there was a greatest common factor of 3 to begin with. So, that somewhat seems interesting. Why is that important to point out? Well, do we even need to check this arrangement? Well, no. 3x and 6 have a greatest common factor of 3, yes? Well, in the starting problem, is 3 the greatest common factor of 3, 7, and 6? Well, no. It doesn't work. If we did check it, x times 6 is 6x. Negative 1 times 3x is negative 3x. Gives us a positive 3x. That is not the middle term. So 1 and 6 doesn't work. And really, we can determine that because, well, I can't have 3x and 6 in the same parenthesis. We have 4 arrangements just kind of with this setup here. So what that tells me is, well, this cannot be 6. Now, could this be 3? No, because we have 3x and 3. So that doesn't work, because if we set it up here, I'll go on and just check it. X times positive 3 is 3x. Negative 2 times 3x is negative 6x, which gives us a negative 3x. That's not the middle term. But out of the different arrangements, just by seeing that greatest common factor, we didn't have it to begin with, so we can't have it here. 2 of our possible arrangements are gone. We didn't even have to try them. Just because we can, if we see that. If we don't, if you notice there, I still checked it, and it turned out they don't work anyways. So we do have 2 more arrangements with these. We can put the 3 here and 2 here. Now, we don't have a greatest common factor between 3x and 2, or 1 and 3. And if we check this here, x times 2 is positive 2x. Negative 3 times 3x is negative 9x. And 2x minus 9x is negative 7x. Is that the middle term we wanted? And that's it. Now, there is another way that we can technically write this answer. This is also correct. Because with multiplication, bless you, because we're saying the x minus 3 is being multiplied by the 3x plus 2. Does order matter with multiplication? No. So 3x plus 2 times x minus 3 is the same thing. It's just written in a different order. You don't have to have both. You just need one of them. Because these are the same thing. Are you ready for the assignment?